Alright, we're ready for 7.2 on graphs, linear equations, and systems. So we'll look at more things we can do with lines. We talked a little bit about slope-intercept form in the last section, but we'll continue that in this section a little bit. If we're given slope m and this b critter, and remember that slope-intercept form is y equals mx plus b, we can simply write plug in the m and the b, and we have our equation. So in this case, we'd have y equals, m is 3/2, so 3/2 x plus b. Well, since b is a negative, we could just write minus 2/3. So there's our slope-intercept form of that equation. Now you might ask, what is b? Well, b is the y-coordinate of the y-intercept. Notice if we put 0 in for x, y would be negative 2/3 because this x part would go away. So I didn't write this up here. Y equals mx plus b is our slope-intercept form. Again, m is representing our slope. B is the y-coordinate of the y-intercept. So if we have b right here, that means that the y-intercept is the point 0, b. Okay? Alright, so let's look at the next one. We're given the m, given the b. It's simple just to plug them in, right? So we get y is equal to negative 7x, and we have plus a negative 2, which is just minus 2, right? So this would be our slope-intercept form. The reason we call it slope-intercept form is because we can look at it and tell that the slope is negative 7 and the y-intercept is the point 0, whatever this guy is. In this case, it would be 0, negative 2. Alright, let's look at the next one. We're given the slope, negative 6/5. This time we aren't given b, but we're told the y-intercept. The y-intercept, if we have it, then b is the y-coordinate of the y-intercept. So we can just plug things in again. Y equals negative 6/5 x. M is negative 6/5. That's our slope. And the y-intercept is 0, 2/5, so we'd have plus 2/5. So positive 2/5 for the y-coordinate of the y-intercept. So questions like that should be very easy. If you know slope-intercept form, you could just plug in the numbers. Now, in the next part, we're going to graph these equations, and it tells us to use the slope and the y-intercept. So you may prefer this method. If you look at this first guy right here, this is not in slope-intercept form. And to use the slope and y-intercept, it would be nice if it were. So let's get y by itself so that it's in slope-intercept form. We subtract 4x from both sides. We get negative y is equal to negative 4x plus 4. Alright, so y is almost by itself, but we need to multiply both sides by negative 1, right? And then we get y is equal to, if I distribute the negative 1, we get 4x minus 4. Alright, so once we have slope-intercept form, we know the slope is 4. I'm going to actually write it as 4 over 1. And the y-intercept is the point 0, and we have our b, negative 4. Okay? So then what I could do is plot the y-intercept. 0, negative 4. And my slope is positive 4. That means we have a rise of 4 and a run of 1. So I'm going to rise 1, 2, 3, 4 and run 1, and I should have a point right here. So I have my 2 points, and I can connect them and get my line. And again, the graphing tool on MyLab is pretty intuitive. I don't think you'll have problems with it, but I'll reiterate this. If you have any questions or concerns about it, let me know. Now the next one is already in slope-intercept form, so that's a good thing, right? We can say, well, the slope is this coefficient of x here, which is negative 3. and I'm going to write it as negative 3 over 1. Your y-intercept is the point, 0, and whatever your b is, which is 6. So I'm going to start by plotting that point, 0, 6. My slope is negative 3 over 1, so I rise negative 3. That means I go down 1, 2, 3, and run 1. And so I have my 2 points. I connect them and get my nice line. Alright, so we're going to stop there. We'll pick up on the next page with the next video.